how we find all these.
Function f of x.
Hello, Math 370. Today we are talking about derivatives. Woo! This is presented by Team Evil, which consists of David, Nat, and Chris. So to start off this topic, we are going to talk about the history. So let's get this out of here and learn some history. So we got this guy, Pierre Fermat, guy with the mustache. He, in the 1630s, dealt with the idea of maxima and minima. So, he had this problem. Given a line B, we'll call this line B, how do we split into two parts, 1, 2, such that the product of these two parts is equal to a maxima? So, let's start that off. So, let's name this part A, and since this is length B, this part is automatically B minus A. Now, let's take the product of these two parts, and that's basically AB minus A squared. But there's a problem. This is not enough info. We need to solve for A, but we can't yet. So what Fermat did, because, why not? He said, let's just introduce a variable E. Boop, 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 boop. Such that the first part is now A plus E, and which makes the second part automatically B minus A. And so the product of these 2 points is now, bam, this. And then this is equal to BA minus A squared minus EA plus EB minus AE minus E squared. So now we have enough information where we're going to take these two together and we're going to solve for A. So we got to set them equal to each other. We get all this good stuff. Beep, boop, bop, bop, beep, beep, boop, bop. And then I'm not going to do all the work, so we're just going to simplify, solve for A, all that good stuff, such that A is equal to B minus E, and we're going to take that entire thing and we're going to put it over 2. But we have a problem. We have way too many variables, and this E is just random. I don't even know why we have this E, but Fermat knows. Fermat basically said, let's suppress E, just get rid of it. He's just disappeared. It's just gone. She's gone. It's whatever. So as a result, we get A equals B over 2. And that's the correct answer. Woo! So, why do we suppress E? Well, suppressing E is kind of like making E small and small and small and small. And like so small that it's almost 0, but not yet. And if you recognize that kind of form, it's like because it has to deal with tangent lines and such that we're going to get this done here and we're going to talk about Morlock calculus. So, boom! Get that out of here. Let's skip some years, and by some I mean a lot of years. So we have Newton, and we're gonna call him the guy with the ears. And then we have Leibniz, and we're gonna call him the guy with the hat. And these two fellas, they basically invented calculus itself. Whoa. They dealt with all these calculus ideas, and basically they thought of the idea of the inverse of integrals. Yeah, that's derivatives, which obviously makes it the inverse of derivatives, integrals. A little fun fact, even though these two were like the creators of calculus, people in the 1700s, they fought. They were like, so, we got the guy with the ears, the guy with the hat. They were like, excuse me, the guy with the ears invented it. He invented calculus first. But then other people were like, no, the guy with the hat, he invented calculus first. And then, even though I don't know if this happened, I'd love to think that like people in the 1700s, they actually like threw fists over who invented calculus first. This is a fight scene, obviously. And just, yeah, people throwing fists in the 1700s over math of all things, I love that. That is hilarious. And so, we have a problem. How do we find the slope of a point on a curve? In fact, how we find all these slopes of all these points, because they all have different slopes, On a line, it's pretty easy. You know, like this point, the slope of this point, it's the line itself. But with the curve, we're not so sure. So the guy with the ears, Newton, he basically said, well, let's take 2 points on the curve. Let's find that slope, you know, that whole rise over run thing, and then let's keep taking smaller and smaller points such that the segments between the original point, let's call this A, the segments between A and all these other points, they get smaller and smaller and smaller, such that we finally get the slope of point A, which is also called a tangent line. Whoa! So, how do we express this idea mathematically? Well, this whole thing, that's basically just the limit of fx plus h minus fx, as h goes to 0, of x plus h minus x. And this is essentially the same as limit of h goes to 0 of fx plus h minus f of x all over h. So, what does this mean though? Well, the top part of fraction, this part, it represents the vertical distance between all these different points, you know. And then the x plus h minus x, or just h, represents the horizontal distance between the 2 points. And then each going to 0 represents us taking all those tiny little segments and making them smaller and smaller and smaller and smaller and smaller and smaller, such that we finally get the slope of A. And so, we are done. The history lesson, done. There, obviously, calculus has some tweaks, and a lot of stuff goes on as the years go by, but we're done. So, as such, we're going to simplify things a bit, and we're going to start the relationship between derivative and slope. And let's get that out of here.
So hi everyone, today I will introduce you to the power rule and I will explain how it works. So let's say we have a function f of x is equal to x to the n power, where n can be any number. So by taking the derivative and using the power rule, we say that we put n in front, we multiply by x to the n minus 1 power, and that is the power rule. Now let me give you some example. Let's say f of x is equal to x squared. So notice that n is now equal to 2. So finding the derivative using the power rule, you with the 2 in front, you multiply by x to the 2 minus 1, which then just gives you 2x. Simple, right? Now let me give you another example. Let's say g of x is equal to x to the 3/4. So now n is equal to 3 over 4. So taking the derivative of x, so put the n in front, you multiply by x to the 3/4 minus 1, which then give you 3/4 x to a negative 1/4. And that is how you use the power rule. You can also use the power rule to find the slope of any linear function really quickly. So let's say we have the function here is f of x equal to 3x. So taking the derivative f of x using the power rule, so you can see here there is a constant. So the trick here, you can actually pull the constant out and then just apply the power rule to x. So x is actually x to the 1, so n is equal to 1. So you put the 1 in front, multiply by x to the 1 minus 1, which then gives you 3x to the 0. And we know that anything to the power of 0 is equal to 1. So therefore, the slope is 3. So to see if it's true or not, let's use the slope function, which is m equal y2 minus y1 all over x2 minus x1, where m is representing the slope in the given 2 point. And so let's say our point is 0, 0, and 1 and 3. So if I plug in f of x, it will satisfy the function. So therefore we say that slope is equal to 3 minus 0 over 1 minus 0, which gives you 3. And as you can see, by using the power rule, you can find the slope without using the slope function. So where you have a nonlinear function, let's say f of x is equal to x squared. So if you draw the graph of the function, it's actually a parabola. So when you take the derivative, it's going to be equal to 2x. And what the derivative function help you, it actually helps you to find a straight line that touches a certain point along the curve. So let's say x equals to 1, so plug in 1, so we got the point. So f of 1 is just going to be 1. So the point we have is 1, 1. Plug it in f prime, so f prime of 1 is equal to 2. So let's say the graph is not try to scale. Let's say 1, 1 is right here. 1, 1. And you know f prime is 2. So therefore, the line that you want to draw is look something like this. And this line is called the tangent line. So now that you know how to do the power rule, let me introduce you to the chain rule. And this rule is really helpful when you try to do the derivative of a composition function. And what I mean is when you have a function inside of another function, and as you can see here, the function g is inside of f. And for our convenience, let's say that g is the inside function and f is the outside function. So by taking the derivative of this whole function, we say that using the chain rule, we say that first we have to take the derivative of the outside function. We keep the inside function as it is, and we multiply by the derivative of the inside function. And that is what the chain will look like. It's look a bit weird, but let me give you some examples so you can have a better understanding of how it works. So let's say I have a function f of x is equal to 3x to the power of 3. And you can see here the inside function is 3 of x and the outside function is to the power of 3. And you know that when you take a derivative to a power, you can use the power rule. So again, using the chain rule, f prime of x is equal to 3, keep the inside, and multiply by the derivative of the inside, which is 3x, and the derivative of 3x is just 3. Simplify, you got 9 multiplied by 3x squared, and you can just leave your answer as this. And let me give you another example. Let's say g of x is gonna be equal to x third plus x squared to the fourth. Again, to find the derivative of a linear chain rule. So this is an inside function. The outside function is to the power of 4. So therefore, 4, keep the inside, and then multiply by the derivative of the inside, which is just 3x squared plus 2x. And putting them together, you got 4 of x third plus x squared to the third multiplied by 3x squared plus 2x. And that is how you do the chain rule.
Chain rule gives us access to two new derivative solving tools, the product and quotient rule. The product rule has an easy to remember equation, which is p of x is equal to f prime of x times g of x plus f of x times g prime of x. So when you're given an equation to solve, such as 3x squared minus 1 times x squared plus 5x plus 2, you'll just have to choose which one's going to be f of x and which one's g of x. So if we choose this one as f of x and this one is g of x, all we need to do is find the derivatives for both. So f prime of x, through the chain rule, we know we can multiply 2 times 3 because it has an x. And we have 6x, and 1 doesn't have an x, so it goes away. And then for g prime of x, we again use the chain rule. We multiply 2 that's in front, 2 by the 1 that's in front of the x, which is 2x plus, and then we multiply the 1 times the 5, and then get rid of the x, which is 5, and then 2 does not have an x, so it goes away. And then finally, we'll just have those together. We have p of x is equal to f prime of x, which we found was 6 of x, times the normal g, which is x squared plus 5x plus 2, plus the normal f, which is 3x squared minus 1, times the derivative of g, which is 2x plus 5. And that's the product rule. So the product rule, very similar to the quotient rule, where it has a formula, which is q of x is equal to f prime of x times g of x minus f of x times g prime of x, and all of that is divided by g of x squared. So if we have a problem, say 4x to the third minus 7x divided by 5x squared plus 2, we just have to again identify the f of x, let's make this more look, and a g of x. Find the derivatives and plug them into the equation. So for f prime of x, we know that we can multiply 4 by 3 and subtract the exponent by 1. So we have 12x squared, and then 7 only has 1x, so we have 7. And for g prime of x, we again use the power rule. Multiply 5 by 2 and subtract. We have 10x, and 2 doesn't have an x, so it goes away. And now we're just going to plug in q of x is equal to f prime of x, which we found to be equal to 12x squared minus 7, times the normal g of x, which was 5x squared plus 2, minus normal f of x, which was 4x to the third minus 7x, times derivative of g, which is 10x. And that all gets divided by g of x squared. And g of x was 5x squared plus 2. And that's the quotient rule. That was our video for calculus. If you liked the video, remember to like and subscribe. And if you have any questions, we went over a lot, make sure to comment down below and we'll make sure we can try to answer.